Well, good morning, everyone. Welcome to today's webinar in regards to VRS discussion. Again, thank you for attending today's webinar. We're going to be focusing our discussion here for the next 30-45 minutes on real-time cores networks, or some commonly referred to as VRS. So we're going to have a discussion in regards to those networks. Presenting this session today will be Mel Philbrook with Frontier Precision. We'll get started on that here shortly. Just a couple of reminders. First thing is, as we do with all of our webinars, this particular webinar will also be recorded for playback so that you can share later with your staff, or you can review it if you want. We will send out a blog message on both of our FPI survey and FPI mapping blogs in regards to its availability, but I would expect it'll be available in the next couple of days. You can check our blog sites, either the fpisurvey.com or fpimapping.com blog sites for that playback here later in the week. As another reminder, everyone is muted during today's session, so if you have questions, we encourage you to ask those questions. Just submit those questions through the GoToMeeting chat interface, and we'll try to get to those, or as many of those at the end of the session. With that, I'm going to turn it over to Mel Philbrook, and again, thank everyone for attending today's webinar. Here you go, Mel.
Thanks, Steve. Jay, Steve, just an audio check. Everybody hear me okay?
Yep, we can hear you fine.
Hey, thank you everybody for attending today's discussion on VRS. And today's agenda, we'll talk about what is infrastructure. We'll talk about what is Trimble VRS. We'll show you how not all VRS are the same. We feel it's important to know your NADs, and what we mean by that is NAD 83 is a datum, and we'll get into that. Some common support questions that we receive, and then we'll change gears to some VRS benefits to mobile GIS users today. We'll show you which Trimble software supports VRS connectivity, and then we'll cover some general setups. Because of time constraints, we have a lot to cover today. So all the general setups that we'll show you will be available and posted on our post blog page that you can download at your will or watch at your own leisure. So let's start off on what is infrastructure. I've been really lucky to be have been involved in my years of setting up single bases and infrastructure in my time at Trimble. And infrastructure has many meanings, but without a stable foundation, a building would collapse. And what we mean by that is we're all exposed to different kind of infrastructure every single day by the use of cellular towers, networks and interstate highways, utilities, oil and gas, and we feel that Trimble infrastructure is an enabling technology, and we hope to show that to you today. We feel it's also important to understand how infrastructure has kind of two values. From an IT perspective, it offers redundancy and reliability, scalability, manageability, and wireless integration. And those are very important things from an IT side of the house. But from a mobile user, it offers accuracy, technology, efficiency, and reliability. And we're going to show you that today also. So why would we want to use an RTN, or real-time network infrastructure? Infrastructure enables the geodetic backbone for an entire job site. It promotes active control. Many people that I've worked with and trained over the years, when they used to have to set up a single base on control, there's always the problem of guessing, is this the right control point? Am I hitting? Do I need to calibrate? All these things. And you'll see here with the use of the real-time infrastructure that we have productivity gains. It's proven that there's less human errors, which means less rework. There's consistency across the project, and a real-time network operates 24/7, which has value. So there's different components to infrastructure. And so what is Trimble GNS infrastructure? Well, GNS infrastructure is the receiver, the PC, the software, and the communication links that are permanently or semi-permanently stationed to provide continuous data logging and monitoring for users in the field, those geospatial users. An infrastructure system is the combined properties of a GNSS infrastructure plus communication links and all the other things necessary to make geospatial users operate in the field. So what are the benefits to some of the benefits to geospatial professionals? You have access to real-time data through cellular comms. Over the years, we've seen there's substantial less learning curve to achieve centimeter accuracies, and you'll see that both from a geospatial surveyor and also geospatial mapping and GIS person. It puts everybody on a common coordinate reference frame, and we'll explain this more in detail as we move on today. And there's an increased accuracy in code differential solutions with little or no additional cost. So before we start defining what a VRS does, it's kind of important to know that over in the early 90s, we used to set up reference stations, not knowing that fast forward 20 years later, there would be this enabling technology called VRS. And we used to set up reference stations either out in the field or on buildings or semi-permanently mounted points like on galvanized pipe anchored into the ground. Located on a precisely known position. That position could have cooked off data statically and that information sent out to Opus. It typically also recorded GNSS data for post-processing and analysis. And it could have been used to broadcast real-time in the mid-90s using radios and now modems. The range on that could be anywhere from 10 kilometers, but using repeaters that could have increased. But there was a part per million degradation because these reference stations would degrade over distance because of the natural deficiency in the environment. So if we used to do that, there was all these limitations of classical RTK surveys. There was limited range from a single reference station. And more today, because of narrow banding, and we have a webinar that was done on the impact of FCC narrow banding on RTK usage. I would encourage you to watch that. But the potential gross error of establishing reference stations, there's no integrity monitoring on a classical RTK-based rover setup. And it's a dependency on a single reference station, so no redundancy. There's productivity loss because of that range. There has to be movements of the reference station from point to point to be able to cover a certain amount of area. There's security, more theft than ever on reference stations throughout our territories and others. And then communications. Even though we tend to work in a world of cellular. There are many areas where cellular is not available, and the single reference station using UHF with UHF propagation and other people operating on the same channels. You have all those issues with communications, and then power supply is necessary to run these bases and rover systems. And lastly, one of the weaknesses of single base or single reference station setups, the RTK system requires receptions from satellite signals that must travel through ionosphere, which contain charged particles, and then through that, our atmosphere, which is loaded with water vapor. So these conditions delay the signal a little bit, and that delay translates in positional error. So even though we can predict what a typical trip through the atmosphere will do to a signal and subtract that from actual measurements, but since no single trip will be exactly typical, these corrections aren't perfectly accurate. But there is a better way, and there is a much better way to get accuracy, and that is through the use of Trimble VRS. So Trimble VRS is a multi-layered service linking a network of reference stations, and these reference stations provide quality control of incoming data. They log files for post-processing. They network model for systematic errors. They're able to alert the VRS operators of conditions of the net, and they broadcast real-time broadcasts of RTK solutions, and most of them are capable of also broadcasting DGPS for mapping and GIS purposes. So why would I want to use a Trimble VRS? Eliminates the need to establish base or reference stations. This reduces time and chance of errors inherent in setting up these bases and all the other things that traditional RTK users have been exposed to. It increases your, you have increased accuracy. You have an extended operating range because accuracy doesn't degrade with distance. There is no ppm, which is 1 to 2 ppm, which is what equates to 1 to 2 millimeters per kilometer. It provides integrity monitoring, and all users are on a common and established coordinate frame. And lastly, on that last point there, established coordinate frame, one of the major advantages of Trimble VRS, and you'll see this as we move forward, is the ability to actually broadcast on several different coordinate reference frames, such as NAT83 2011, NAT83 Cores 96, or NAT83 1986. VRS is easy to use, and today most Trimble survey systems and certain Trimble geospatial mapping systems are able to tie into VRS systems. They receive information from permanent reference stations that are operating 24/7 around the region. This GNSS data is streamed via LAN or internet links or private modems back to a central processing server. And this central server computes correction models for the specific area or region. From a user standpoint, the user in the field makes a connection to the in-trip server via a wireless internet, and that can be using a Verizon or, excuse me, an external MiFi, an internal modem built into our devices, or in some areas where you have Wi-Fi anywhere. When the user makes the connection to the in-trip server, it provides a list of available data. We call these mount points, and we'll get into this in a minute here. And the user will select the correct or appropriate mount point and flavor that he needs for his specific receiver. which is manufacturer independent. This VRS system, this Trimble VRS system, works with all manufacturers. This in-trip caster communicates with Pivot, our backbone software, and this Pivot provides custom solutions for users for the solution for the user's location. The field user then receives real-time data corrected for local atmospheric conditions. The base is virtualized near him, reducing or eliminating the 1 to 2 ppm. The rover operates with enhanced efficiency and quality control because of this. This is how easy it is to use a VRS system from Trimble and the advantages of Trimble VRS. So what this picture is trying to show you is that today there are many types of GNSS receivers, and there is a trend to bring your own device. And some of these devices can use also cellular-based corrections. If you're using a BYOD device today, that standalone GNSS or GPS receiver is probably 5 to 10 meters of accuracy. If you're using a DGPS source, that could be Coast Guard beacon, it could be space-based augmentation system, it could be a flavor of Trimble RTX. Those accuracies are typically a half a meter to 1 meter. There's also Trimble H-star corrections available through VRS Systems, and also a flavor of RTX that's equivalent to this H-star that will give you 10 to 30 centimeters of accuracy. And then there's VRS, and VRS will achieve 1 to 2 centimeters of accuracy. So we often get questioned or asked the question, aren't all VRS systems the same? There are many different VRS systems, both publicly funded, privately funded, and available in your region. I would encourage you to do some research in your particular area. In our territories, we have Trimble positioning services being run by Trimble, offering a variety of positioning services, anywhere from RTX to VRS, and flavors of both. We're also very lucky to have the Minnesota Department of Transportation, who has established a complete network of M-Cores network covering that state. And I will like to say my years of experience where you see free available VRS, you see an increase of geospatial work, an increase of the advantage to agriculture and many different industries from this this network that Minnesota Department of Transportation has done here. And then we also have a network from Mesa County, Frank Achiever's Mesa County network, which is RTVRN, covering pretty much the western half of Colorado. And again, this is a free network that's been grassrooted from great people. What I'm going to show you here is that these networks have websites, and when you're going to be using anybody's VRS, I would encourage you to go back to the website that's managing that particular network. Here's one for Minnesota Department of Transportation. The Mesa County, if you click on this link, you'll see that Mesa County has a complete network in all the RTVRN info, and also Trimble Positioning Services has their dedicated website for all their services and information about those services. Why we're showing you this is that is to, again, not all VRSs are operated in the same manner, and so therefore they're not all the same. Some are free, some are paid, some offer more than others in reference to flavors of correction services and portfolio. And we encourage you to always research the particular VRS that you're going to use to understand how it's operating. So let's change gear to knowing your NADs. This is kind of a term or that's often confused. Just last week I was operating at a particular agency, and I asked, what's the reference station coordinate system? And the person replied to me, it's NAD83. And we commonly hear this from geospatial users that I'm operating in NAD83. And so we wanted to take the time to educate everybody that what the definition of a geodetic datum is. A geodetic datum is a set of constants specifying the coordinate system used for geodetic control. And you need to understand then NAD83 is just that. It's a horizontal control datum. So NAD83 is a horizontal control datum. And if you want to know more about NAD83 and a tutorial on datums, this NGS NOAA tutorial on datums is a very excellent resource on understanding what datum my data's in, geodetic datums, reference ellipsoids, geoids, horizontal datums, and vertical datums. It's a great resource. I encourage you to go there on your own. So let's also make sure that everybody on this webinar understands that NAD83 is a datum that has had many realizations. 1986, HARN, CORS, NSRS, 2011, they're just to name a few here. And it's important to understand that because you'll see as this demonstration goes on, if I'm operating on NAD83 CORS 96 versus NAD83 2011, and I have settings set up improperly, and I have a centimeter device, you'll see that you're not going to be anywhere near a centimeter. So to say that you're on NAD83, hopefully after this webinar, you'll learn not to ever say that again. You're NAD83 something, and you should know what that is. NAD83 2011 is the most current realization which all NGS core sites and NGS Opus use, operate from, and if you send something to Opus, that's the answer you're getting back. It's a NAD83 2011 EPIC 2010 position. So how can I tell what NAD realization the VRS provider is using? Well, that's what we're going to get up to next. I'm going to switch this over to Steve Richter because this particular slide is in a network that he's more actively involved with and wants to be a part of.
Okay, thank you, Mel. So a couple of things here. One thing of note is with the Trimble real-time network or VRS network systems, they have the ability to provide as an option, a transformation within the VRS network. And so in this particular case, when we're looking at these series of mount points that you see here on the screen, on the left-hand column, this happens to be the Minnesota DOT Corps real-time network. You'll notice that they have different realizations of NAD83 in parentheses, just like if you were looking at a NGS data sheet in the past, or if you're looking at a Minnesota DOT the data sheet, they have different realizations. And so you can see that the first group column here is a 1996 NAD83 mount point. And then you have a 1996 HARN, and I'll explain the difference between the two here in a moment. Then you have a NSRS, as Mel alluded to, a 2007, and then you have 2011. And the 2011 is where things got confusing. But before we go to the next slide, I do want to explain a couple things here. First thing is for those of you that are on today's call that are using the Minnesota DOT cores, the difference between 96 and 96 HARN. 96 was the first mount point that the VRS system provided back in its past, we'll just say. At that time, there were only a certain number of reference positions that they could use to determine the relative position of these core stations relative to 1996. As the years progressed and they provided more detail and more stations came online, and there was a new adjustment that was done by the geodetics department at the DOT, and they renamed that adjustment 1996_ HARN. And they are in the same realization. It's just that one being a little bit more complete in regards to having more control available at the time to provide a more clean or a better adjustment to 1996. So the key here is if you're doing new projects and you want to work with the 1996 adjusted positions, you would use that mount point, the 1996_ HARN. If you have old projects that you've used the old mount point, just 1996, you would want to complete that job in your data collector with that same mount point. But I would encourage you, as you move forward in 1996, you use the _HARN mount points. The other two speak for themselves. If you're working in 2007 and you want to have your data adjusted relative to 2007, you'd use that mount. And same thing with 2011. If you want your data adjusted now to 2011, you would use that mount point. Also notice the NGS suggestions for geoid models as they relate to each mount point. And I also saw a question in regards to vertical and VRS, and we'll get to that question at the end. But hopefully talking about the geoid model here and some of the next slides coming up that will help you understand what you need to do to get the best vertical out of a VRS system. So again, 2011 recommend GeoID 12A, 2007 recommended GeoID 09, and then 1996 recommended GeoID 03, and that's just how those adjustments were made by NGS. Okay, we'll go to the next slide there, Mel. So one of the most common support questions, as I just alluded to, is if I'm working with a VRS or a real-time system, is performing a site calibration or localization necessary? And in many cases it is, because again we're going off of a reference position that us or our project may not have any control over, meaning the reference position coming out of that system may be 2011, and that's all that we have as a choice, but our project needs to be done relative to the 1996 or 1986 adjustment. So in that particular case, a calibration would need to be done. Same thing with vertical. If you imagine one of the maps that Mel had shown here earlier, and you imagine the size and scope of one particular network, and we'll just take Minnesota as an example because it's a large state. Keep in mind that to create a network, just like if we were doing a least squares a network ourselves with fast static GPS, we have to have things tied together. So with all of these stations, all of the vertical has to tie together from one part of the state to the other part of the state. So it's a large vertical control network. Well, that doesn't guarantee that if I dial into this network in the middle of the state that my position, my reference position, is going to be relative to the vertical control that I am coming off of. And in fact, 9 times out of 10, it's not going to be. It's going to be off. And we've seen anywhere from being within a couple hundredths of our vertical control point to 2/10 of a foot vertical difference. And that's not uncommon. And you would expect that. The same thing would be true as if I set up a single base reference station on a control point with no vertical, and I went and tied into a vertical benchmark and I was off 2/10. It's the same principle. It is no different, to be honest with you. you still need to do some type of vertical calibration to get your GPS accurate vertically on the system, and that is a function of any GPS. So is performing a site calibration or localization necessary? And the answer to that would be absolutely. It just depends on the project and what's being done there. So you can see a couple of notes that we put in here. If you're pre-selecting the coordinate system in your data collector, like county coordinates or state plane, the horizontal calibration should only include 1 point. More points added into the calibration horizontally could negatively impact your coordinate system. Now vertically, it's a different story. If you're using a predefined coordinate system, the only thing you're predefining in that coordinate system is the geoid model. You are not predefining the vertical adjustment. You're getting a reference position relative to your position, and that reference position is going to use the geoid model plus the ellipsoid height to give you an elevation. So if it's not very good in the area, or if it doesn't match your vertical control, a vertical calibration may need to be done, and that should include 1 point or more than 3, so 1.4 or more for the vertical calibration. If you do not pick a predefined coordinate system like state plane or Minnesota County coordinates, and you choose no projection, no datum, then your horizontal calibration should include 3 or more points, and your vertical should include 1 for small projects, or 4 or more points of vertical. And a big note here, remember that this can only be determined to any degree of certainty by actually measuring good control monuments in your area and examining what those differences are. And that's what we should be doing with any GPS or any type of surveying, whether it's using VRS or a single base. Okay,
Hey,
we'll go to the next slide. Yeah, go ahead.
You might want to mention to them that you typically sometimes people get confused of mixing 1986 with 2011. Yes. Let's just say. Yep.
Yeah, so one good point. If you have data sheets, and some data sheets now will only show you one adjustment, like 2011. Some data sheets will show you multiple realizations. Say, for instance, in Minnesota, a data sheet might show you 96, 2007, and 2011. Don't mix and match those. So don't calibrate to a couple of points on one realization and calibrate to a couple others on another realization, because if you do that, you're going to be mixing and matching those realizations, and it's going to basically add error into your survey. So keep those consistent. One other thing, this is important to note when using just the Minnesota County coordinate system, because of those coordinate systems that are predefined in your data collector and they're transformed to ground already by the system itself. Sea level correction under your COGO settings is very, very important. So if you notice that setting under COGO there at the bottom, that should be your COGO settings for almost all of your projects. Now we exclude that when using these 8 counties that we define here, and those are Mercator, transverse Mercator projections with no adjustments being applied to get to ground. So in that particular case, you want to uncheck that sea level correction as you note for all counties except for these 8. Those 8 counties that are listed here, if you're predefining and selecting those coordinate systems, you want to check that sea level correction checkbox. All other counties in the state are unchecked. And one other thing that comes up a lot is we'll get calls about, hey, I'm getting a new phone or a new MiFi device. How much data is being consumed by my VRS? Because now a lot of these data providers like Verizon and AT&T and T-Mobile and Sprint, they are charging by the gigabyte. So so one of the things that the Department of Transportation did here a while back is they determined the amount of data, and we verified this here within the last 30 days. We verified this data is proper and correct. These forms here that you see. If I'm using different correction formats from the VRS, because you'll get that when you connect up, you'll get choices like our TCM 3.1. You get a choice of CMR Plus or CMR X. how much data is being received and how much is being throughputed to your controller from the server. So hence, how much data do I need to use, or am I being used in a monthly period? So you can see the CMRX message is quite small compared to the old RTCM 2.3, which we do not recommend using. RTCM 3.1 is much smaller, closer to CMR Plus. And you can see that data over an hour period varies by satellite, but it's around the 1,000 K per hour or less range. And if we look at this in a little bit different slide, we'll change slides here. No. Thank you. You can see the data usage over time. So if you plot this out to, say, for instance, 20 satellites or so, which is entirely possible to receive nowadays, at 20 satellites with CMRX, you'll notice that you don't increase the data storage or the data received or being used by your system significantly like you do when you're using CMR Plus or RTCM 3.1. So that is a huge advantage of the CMRX. It keeps your data usage very, very small. But you could even see with CMR Plus at 20 satellites, if we go over to our chart on the left, CMR Plus is going to be about 1,300 K per hour. So you're even going to be, even on 50-hour work weeks, you're going to be less than 500 megabytes in a month. So 1 gigabyte plans should be sufficient for everyone. So hopefully not to confuse everyone, but I want to point this out. This is extremely, extremely important because we've seen a lot of questions and problems with this NAD 83 2011, especially when it was first introduced as a coordinate system in the Trimble software, and that's both in the handheld and in TVC. So as of version 1249 survey controller and access 2012.2, when using VRS, your Trimble data collectors will always assume that the broadcast position is WGS 80. Fine, and that works well, especially if NAD 83 and 2011 are virtually the same. And they are, depending on what datum transformation and or coordinate system you choose. So if you know, many VRS systems are now broadcasting a NAD 83 2011 position, and you saw that in the chart that we had shown earlier. And this is also true for even some of the single base reference stations. If the controller coordinate system and datum transformation is using a 7-parameter transformation as referenced above in NAD 83 Cores 96 or the NAD 83 2011 systems, WGS 84 in your local position will not be the same, and that will produce an incorrect value in the field. So, for example, if the VRS is in fact broadcasting NAD 83 2011 and you're working in Colorado, State Plane, NAD 83 2011, which is now called ITRF to NAD 83 in your data collector, that is the choice. If you choose ITRF to NAD 83 State Plane in your data collector as your coordinate system, the Trimble data collector will interpret the broadcast lat long as a WGS 84 position, which is not correct. It is a local position, and it will retransform that position to a new local value, and thus your grid coordinates will be off, and it will be off by feet. It will be pretty significant. For that reason, we always want to suggest to users to use the NAD 83 CONUS state plane coordinate systems in your controllers and in your software, and then you can transform from there to 2011 ITRF if you're required to do so. But when you're working in the field, we always suggest you to use the NAD 83 CONUS selection within the data collectors. All right, I'll turn it back over to you, Mel. Thank you.
Hey, thanks, Steve. So we're changing gears a little bit now over to the mobile GIS user, and it's important to understand there's some things that you some benefits and some things you, as an operator, you need to know. So why would I use Trimble VRS as a mobile GIS user? I've been in the utility. When I worked in government, I was in utility facilities, and so I was always a big proponent of high accuracy GIS. And so VRS offers to a mobile GIS user is it's increased accuracy. It's better than WAS. It's better than Coast Guard Beacon. It's better than OmniStar. It's even in some ways, well, it is better than the RTX feed from now formerly OmniStar, which is Trimble Positioning Services. It doesn't degrade with distance from the base. One of the other advantages, again, if you have if your data has been collected, your GIS has been built on the system, all the users are in a common established coordinate reference frame. So it's best fit of GIS data with survey and cadastral framework in mind. The integrity monitoring gives you the ability for quality assurance and quality control checks. And the other thing is some of these former systems like space-based augmentation, which is WAS in the United States, and other satellite-based correction services don't work well in urban areas, inner cities, or under canopy, and you'll see that the VRS does. So some issues for for an infrastructure user and to be noted is most VRS networks are primarily aimed at RTK users. However, more and more network operators are becoming or understanding the value for high accuracy GIS users in the field, and more manufacturers are producing receivers to enable what we call high accuracy GIS. But these networks generally output an RTCM 3x or 2x, and they can actually have the option to output a DGPS solution, and Trimble can utilize that. So Trimble utilizes the RTCM 21 packet, which is RTCM is a group that publishes a standard or conditions for certain packets of messages, and these pseudo-ring corrections can be utilized to produce DGPS solutions to code-based receivers. Some of the higher accuracy devices like the G07 and the 6000 series are using carriers, so this is not applicable to those receivers, but there are some legacy receivers out there that are still able to use DGPS and don't realize that VRS can do that for those operators. Now, what I thought we'd do real quickly is I created a video on how real-time settings can impact VRS corrections for a mapping person. So let me escape out of here and bring up this video. So this video is basically showing you a tech talk that we produce. All these tech talks on setups and everything will be available on our blog post the webinar today. And what this webinar is trying to show you here is that we have a Geo 7 on a monopole operating on a position here to a high degree of accuracy. And we're going to switch to the navigation screen here, and we're going to load some waypoints. These waypoints were cooked off using a R10 receiver for plus 2 hours and sent to Opus. So you first need to understand that we're dealing with control points that are operated in NAT83 2011, and we're using a VRS that at this time when this video was created was operating on Cores 96. So 2 different systems, okay? Apples and oranges. But if you know how to set things up correctly, these 4 points, these 4 Opus control points are on NAT83 2011, and what we're going to do is show you that with settings set up correctly, you can navigate to these points. So this red X is my coworker Zach live in the field, and this point is Opus point 1 that I'm setting target on. So as this person, Zach, navigates to this point, you will see that when things are set up properly, and you can three-dimensionally do high accuracy GIS, collect data, and navigate back to a very high degree of accuracy. So as you see here, he's moving to and onto the point, set up with a monopole with a Geo7. And this is not the best environment. There's some trees, and so the accuracy is not around 1 to 2 centimeters like normal, but you'll see that we have very good vertical, and we have distances within spec. So everything's looking good here because 1, the real-time settings are set up properly. 2, we understand what the control points were. 3, we have a good receiver capable of hitting manufacturer specifications. Now what we're going to do here is now change things up, and this is unique to Trimble mapping systems, that we can actually apply a datum transformation from a real-time source. So under real-time settings, we're going to click the wrench, and we're going to see here that we're applying a NAT83 Cores 96 datum transformation to a real-time source. And by choosing NAT83 CONUS, we're applying no transformation. So now we're operating on a Cores 96 network, applying no transformation, trying to hit NAT83 2011 points. So as I move to this point, you see Zach moving there with a red X, and we're going to pick that target and set target on that. So pick and hold, set target, go to that point, and you're going to see what a #1 support call is on apples, what I call mixing apples and oranges. So switch back to the navigation page here, and let's see what's going on here. So as he moves within the 3-meter range, the alarm pops off saying you're arriving. The circle pops up, which is the target. He's coming onto his point. He's going to set up right on top of the point, and he would collect data. Now, it's important to understand, if you didn't check or didn't know what you were doing, you would be collecting on the point, but you're really 1.14 meters off of the point. So Zach's set up, but he's 1.14 meters away from that point. Vertically, he's somewhat okay, but he's off the point. He's not physically off the point. He's off the point because he's applying a real-time transformation using, and right now not applying a real-time transformation, and he's mixing apples and oranges on the coordinate system. So by going back to real-time setups and settings, and now apply a proper datum transformation. So from no transformation to apply a proper transformation to match the network, he's going to not move. He just pretty much did that by just changing the settings, and you'll see that now we're hitting within specifications, plus or minus 2 centimeters on the horizontal, and vertically everything's good. So that'll be posted on our post webinar, but I'm just trying to make sure everybody saw that, because it's important. So what Trimble software supports: VRS connectivity, Trimble Access, Trimble TerraFlex, Trimble TerraSync, Trimble Positions for Esri ArcPad, and now Trimble GNS Status Utility for the new Trimble R1 receiver. And that's important to know because the Trimble R1 is empowering those who have bought or believed in bring your own device and using, Android phones and Apple products or iOS products, and realize that the accuracy is not consistent, not repeatable. You can use the GNS Status Utility, use it to hit VRS and achieve 50 centimeter accuracies or better. So setting up all these Trimble softwares, due to time, we we wanted to make sure that everybody attending this we're good at keeping our promises, but to keep it respectful to your time, we have two blog sites, fpisurvey.com and fpimapping.com, and these sites will have a post of today's webinar, all the material that you saw today, and all the how to set things up. So you'll see how to set up Trimble Access, which is how to set up a GNSS contact and a VRS survey style, how to set up Trimble TerraFlex for use for Trimble real-time networks. Same thing with Trimble TerraSync. Same thing with Trimble Positions, and the new Trimble GNS Status Utility for the Trimble R1. We're going to change gears here because there's a piece of shareware that's available, and that's this Lefebvre N-Trip client software. And why is that important? Well, you see it running on an Android phone here, and you see it running on a desktop. We get a lot of support calls. You know, is the Minnesota network down, or is the Trimble Colorado VRS now down, or is the Mesa County network down? What you can do from your phone is actually test your username, mount points, and everything, and know if it's down, because sometimes it's your personal someone fat finger and a typing of their password. And so what you're going to see here is I'm going to launch my Lefebvre N-Trip client. You'll notice here if I hit edit and I change this mount point to port 2101 and hit connect, notice how this just downloaded a source table, and now you notice I am on 2011 mounts. These are the 2011 mounts that I could hit and connect and test. Is the VRS, Colorado VRS now working with my username and password? And it is. I could disconnect, and again, this was the importance of mounts. Some places, everything's mounted on 2101, but in Colorado VRS now, all the former Cores 96 mounts are mounted to 2103. So now you notice that I have Cores 96 mounts available to me, and again, I can check and make sure that those are working properly with my username and password. Great freeware that I recommend you download for if you have an Android phone, if you have a PC, and I'm sorry for those Apple folks that it's not made for iOS. Lastly here, I've got to give a Jay Haskamp a plug here. We have built a Frontier Precision app. All our tech talks, all our webinars, all our support resources are available, and it's a one-stop resource to everything you need. You can use a QR code and take a picture of that right now on your screen, and you'll be able to download that app from Android or which is Google Play, or iOS from Apple Store by just using a QR code on that bar. And then lastly, we're open for questions, and appreciate everybody who attended today's webinar so far.
Thanks, Mel. A couple of these were posted and answered, but I'll go through them. First question of the PowerPoint be posted, and we will post a copy of the PowerPoint along with the playback here, and I would expect it to be up by Wednesday, something like that, to give us a couple of days because there's some editing that needs to be done. Another question, are vertical accuracies better with VRS as opposed to set up your own base station? So it goes back to the site calibration that we discussed in the webinar today. That's all relative to the site calibration. Like I said, when you just log into the VRS and get a vertical, it's all relative to the VRS elevation and your geoid model. So if you're checking into a benchmark that has no relation whatsoever to the VRS, then your vertical is not going to match. So a vertical calibration may be necessary. Once you calibrate vertically, just like you would with a single base, then your precision should be just the same as if you were setting up a single base with part per million error relative to where you did your calibration. If you use multiple points of vertical for the calibration, you're going to get a better result. That's just going to be just like a single base. It is no different. So I would expect that your accuracy should be the same. It's just a little bit of education. You can't just log into the VRS and expect you to hit every vertical. It's just not going to happen. Just like if you set up your base on different positions every day, you're going to get a different position on your vertical control that you check into. Other users found VRS may lose fix easier, faster than if using RTK base station. And it's much the same, but we're just not paying attention to it, and Jay answered this as well. It's likely related to a cellular service. One thing is to keep in mind that the voice and the data services are different. You know, as an example, if your phone says it has 3 bars of voice, you may not have that same data service. Keep that in mind. You can watch some of this stuff in your data collector when you are connected to the VRS. In the upper right corner of the screen, when you're using Trimble Access as an example, you have a little icon that looks like a radio or a VRS connection, and it should be kind of flashing for you, and maybe Mel will kind of bring up an example of what that looks like. But when you have that up, you can tap on that particular icon. As you can see, he's bringing it up here for you to maybe show you what it may look like. If you tap on that icon, there is a base data age, and you want to pay attention to that, especially in areas where you're not going to have as great a cellular connection as you normally would. If you tap on that icon, that base data age should be around the 1 to 2 second range, and if it's much higher than 1 to 2 seconds, like 5 seconds or 10 seconds, then you have some poor data service, and that's going to affect, if you lose fix, it's going to affect your precision, and you may be required to stay in your position a little bit longer. So in areas where you're not getting the great data service, you may pay attention to that little icon a little bit better and see if for instance, you're getting some base data age that is outside the recommended 1 to 2 seconds, and that could be definitely why you're losing a fix, or also affect your precisions as you're measuring. So the same thing would be held true if you are using a base station and a base radio. So so pay attention to that. Are there other VRS systems utilizing cellular modems currently operating over a wide area? So the systems that are in use today are in Minnesota. There's one in Iowa. There's a network going up right now in the Dakotas that will cover North and South Dakota. The first part of the network is going to cover eastern North and South Dakota and move west. That's called the Mid-States VRS. It's not online. It's not. You can't log in or buy subscriptions to it yet, but you will be shortly. The one thing that is different, and that is a question that came up, if the cellular modems are correctly directly to the core site with a network cable or internet connection, or with the cellular connection. So for instance, in Minnesota, all of the base stations are hardwired from the base station back to the server. So that is a function of the VRS network itself. The Mid-States VRS that's going up in the Dakotas is going to be using a VPN to connect those base stations back to the server. So it's all one connection, so it's a little easier to particularly manage on a base station to base station. But that's being managed by Mid-States VRS. And the example of the hardwired connections from each base station back to the server, that's being managed by the agency that has the network. So that isn't something that somebody in the field has to worry about. That should be done on the server side. Wisconsin VRS, we don't operate Wisconsin, but I did post a link. It's to wiscors.dot.wi.gov/Trimble Pivot Web. That is their interface. You can go there. You can request access, and you'll get an email back from them with a username and password, much like you get with the same thing when you request access to the Minnesota DOT course, and you can get information that way. That's the Wisconsin VRS. Use a cell phone to connect to a couple bases, and that's a single base connection. In Southeast South Dakota, definitely notice issues when the cellular signal affecting the precisions and receiving while using a cellular connection. Again, that's that base data age. that precision is going to ramp up if the age is old, so pay attention to that while you're surveying. The system will now use a cellular connection for both the user and the network. Will that cause you more issues? No, they're totally different. So the base station back to the server connection is a VPN connection, so it's not anything to do with a data service, so it's not going to create problems with tying up data service. Even the data service itself, you saw that it doesn't use a lot of data, quite honestly. So it certainly is not going to tie up or make that worse. That is just a function of the particular service that you're using. If, say, for instance, it's Verizon, if they have good coverage there for data. That's just a function of that. Again, pay attention to that base data age by clicking on the radio link icon as an example.
Hey, Steve.
Yeah.
On that, since there's a lot of questions, we'll create a little tech talk on how to verify base data age. And again, I'm not sure we kind of made it really clear. There's a lot of people who are using their cellular phones and the data from those cellular phones as a tethered device via wireless for your hotspot. And we've seen that dedicated data devices, and that's these external MiFis, are designed to do one thing and one thing only. That's data. Phones were set up to do both receive phone calls but also do data. We have seen side by side where you have a dedicated MiFi device, you won't have these issues of interrupted data packets as much as when you use a phone as a Wi-Fi device or a hotspot.
Thanks, Mel. Next question, when working multiple jobs over a large area such as an entire county, would it be best to have one calibration vertically for the entire area or multiple calibrations for each site? You notice your vertical stuff is relatively very, very, very localized. Maybe it's a benchmark loop that went through town, or maybe it's a loop that went along a railroad, or maybe it's a loop that provided vertical control to a bridge. Unless those vertical control points that you're going to calibrate to across the entire county fit together well, I wouldn't recommend doing an entire county vertical calibration. If they do fit well, then that is something that you can do. But if they do not, then you're going to have to go off of multiple calibrations for each site relative to how those vertical points and control points were established. Completed a study translating the loss of productivity versus VRS as money saved. There are some ROI stuff that is available. I think Trimble has done some things. We'll see if we can't dig some of that up and respond to you directly with that, Mike. Frontier hasn't done any of that other than just noticed advantages, but we haven't done our own study, so to speak. But I think Trimble has, so I'll see if I can find something for you on that. As I noted earlier, there are other VRS systems coming online. The one that I referred to in North and South Dakota, that is not online yet. It is underway, and a lot of it has been built, and there is some testing going on. You can go to midstatesvrs.com. I'll put that in here. That website. And get more information about the coverage map and what it's going to cover. That website is live, so you can go there. We currently don't have Trimble Rover. How difficult is to use your VRS system? It's not too difficult. It just depends on where you want to get corrections from and what system you want to use, what geographic area you're covering. If you go to one of those blog sites that Mel had brought up earlier, the FPI survey or fpimapping.com, and you can get more information there on how to set up and how easy it is to use the system. When will the Trimble VRS in North Dakota be available? I would expect it's probably going to come online here by the middle, if not end of spring. And that's not up to me, I'm just quoting what I've heard. So stay tuned and pay attention to that midstatesvrs.com website. I'm sure there'll be more information there. Appears the datum assignment is important for collection appearance. Where are you in relation to your data? Did Trimble SDK to the iOS location services to avoid the WGS84 location? That's just going to be an issue all the way across the board. I can't speak, for instance, to the Trimble SDK, but if you use the system properly as we advised and use 93 CONUS, or if you have to use ITRF to 93, which is what it's called now, to get your 2011 positions, you just make sure that you put that in as your local position and you'll be fine. But when you're coming from a reference station, a reference network, it's going to come across as a WGS84 position. So in those particular cases, you're going to have to use the 93 CONUS solution as your datum choice. And that's not so much of something that's done wrong, that's just the way those are handled. So those datum transformations are just that, they are transforming. So you can certainly collect a 93 CONUS and transform to ITRF using a transformation in TBC and take care of that issue if you want. Have you discussed Centerpoint, or is it out of the scope here? So we just brought it up briefly, but we have not discussed it at length. You know, if Mel wants to take this for 1 minute, because virtually we are out of time, but if he wants to take it for 1 minute, you can describe what Centerpoint RTX is. Mel, are you still online?
Yes. The person asking the question about Centerpoint RTX. So Trimble acquired probably over 5 years ago the land-based portion of the satellite corrections from OmniStar Food Row, and that OmniStar portfolio became Trimble Positioning Services, and from that portfolio RTX was born. RTX is offering different flavors, and the best thing to do is probably just bring up that website, which was right here. These Trimble Centerpoint RTX, Trimble RangePoint RTX, and Trimble Viewpoint are the best analogy would be similar to what OmniStar, HP, VBS, and XP used to be. However, these RTX solutions do have a coverage that's can be used for and purpose for ag, construction, etc. And then the thing to understand is that they have different abilities in accuracy. So from center point to range point to viewpoint. For example, Viewpoint was just launched recently for the Trimble R1, and center point and range point have different convergences. So if that person would like to know more about that, or if anybody would like to know more about Trimble Positioning Services, RTX solutions, which is center point, range point, or viewpoint, I would encourage you to reach into a Trimble distributor, and we would be more than happy to explain to you how these three services offer value similar to VRS, that the ionospheric and tropospheric modeling is being handled, but it can be delivered via cellular, and it can be delivered via satellite-based, and they both have advantages and disadvantages because of that.
Can you go back up to the sea level correction slide?
Sure.
I have one last question in regards to explaining the COGO settings again for sea level correction. And this is very important when using, when choosing the Minnesota County coordinate systems. In every county coordinate system, our suggestion is grid as your COGO distances and sea level correction or the ellipsoid correction unchecked. That's our suggestion, except for these 8 counties. These 8 counties do not have a 7-parameter datum transformation. These 7 counties are defined as transverse Mercator counties, and we suggest to have sea level checked on for only these 8 counties. That's the bottom line. And we do have a document on this, Luke. I can send you that document that explains this in more detail. But in a nutshell, all counties except for these 8 uncheck this checkbox under COGO settings. If you're working in these 8 counties, check the checkbox. That way your distances will be proper, especially when using a total station and GPS together in the same job. All right. Again, thank you very much. Sorry we went over time here. We'll have this playback available here in the next couple of days. But again, thank you for everyone's time. This concludes today's webinar. Thank you.